Good morning to one and all. In this class, we are going to see about the first topic of Power System Analysis, Unit 1. Need and need for power system planning and operational studies. So, how to plan the power system for the power system for its future requirements. There is a power system and there will be certain requirements for that. Such as various loads will be commissioned, and so we have to plan accordingly about the various power plants and power system. How to plan for that? First we have to see that, then how to operate it. So a simple overview has only been given, so kindly watch this video. Thank you.
Need for system planning and operational studies. So what is a need for system planning and operational studies? So there are three important things for planning and operation of power system. One is load flow analysis, short circuit analysis, that means a fault analysis. Then third one, transient analysis, call it as a stability analysis. Okay, so for this three analysis we are going for a system planning and operational studies. So what do you mean by load flow analysis? So load flow analysis is determination of voltage, current, power and reactive power. So real power and reactive power at various points in an electrical network. So the main objective here, to identify the potential problems in terms of unacceptable voltage conditions. So that is due to some fault or overloading or decreasing reliability or any failure of the transmission system to meet the performance criteria. It's the main objective of the load flow analysis. And second one, to determine the effectiveness of the alternative plans developed to prevent the foreseen problem, that is these problems, unacceptable voltage conditions, overloading, decreasing reliability, and these problems along with that for the future development. Example, addition of new loads, new generating station or new transmission line. So this can be analyzed using a load flow analysis. How much load is traveling here from one point, from sending end to receiving end. 100 megawatt of load is traveling, whether the transmission line is withstanding that much amount of load, how long it will withstand. This data can be taken from the history, and we are planning and we are studying those things, and based on that we can erect a new generating station, at which point we need this generating station, a new transmission line, whether we need a new transmission line or we can use the existing transmission line in an economic manner. Okay, so these things can be analyzed and planned and studied using the load flow analysis. And second one is a short circuit analysis. So here short circuit, in the sense it is a fault. We are talking about a balanced fault as well as the unbalanced fault. Three phase fault we call it as a balanced fault, and this three fault we call it as a unbalanced fault. In some cases we'll be having an open conductor fault also. Open circuit fault also can be possible. So this can be analyzed, and which location the fault occurs, immediately we need to take preventive measures and open the circuit breaker. So the main objective is to determine the current interrupting capacity of the circuit breaker. So for this particular line, how much fault current will be flowing, that can be analyzed, and based on the fault current value we need to install the circuit breaker with that capacity. Then third one is the transient stability. Transient stability is defined as the ability of the power system to remain in synchronism or a stable value under large disturbance conditions such as fault or switching operation. Sudden fault occurs to the system, then there will be an oscillation in the system. So there will be a voltage fluctuations. Okay, so that we call it as a disturbance. And in some cases there will be a switching operation, sudden inclusion of load or sudden removal of load, then it will lead to a disturbance to the overall system. There the stability get disturbed. So once the stability get disturbed, after that it comes to the normal value. Okay, after the large disturbance, whether the system comes to the normal level, that we call it as a transient stability. System to remain in synchronism. After disturbance, it comes to synchronism again. Okay, which is a stable state again. After the large disturbance, we call it as a transient stability. And need for analysis. So why we need to analyze these things? Provide reliable, uninterruptible supply. With this, I want to tell one more thing. Need for analysis. What are all the analysis? Short circuit analysis, power flow analysis, and stability analysis. So what is the need for these three analysis? To provide reliable, uninterruptible supply to the load, or we call that as a load dispatch. Then both voltage and frequency must be within closed tolerance so that consumer equipment may operate satisfactorily. Okay, so we are in our house we are using so many equipments, okay, electrical equipment, electronic equipment. So if continuously if we are facing a voltage fluctuation, then our equipment equipment won't work. Okay, so there will be some fault in the there may be some malfunction in our equipment. So in order to avoid that, we need to receive a quality of power. That power utility company, they have to provide a quality of power to the consumer. Okay, so the quality of power can be decided with this two factor V and F, voltage and frequency. It should be maintained within the closed tolerance value. Okay, so the voltage will be calculated in terms of a per unit. That is, voltage is, the tolerance value is plus or minus 0.05 per unit, and the frequency plus or minus 0.5 hertz. Means in India we are using 50 hertz, so 49.5 to 50.5 is allowed. So that is a border, that is 49.5 is also very less. We have to maintain with the closed tolerance. Okay, so nowadays if you see in the SLDC, they are maintaining 49.95, 49.93, 49.94. So like that, very close values they are maintaining. Okay, so thereby we are getting the quality of power. Okay, and second one, as electric utilities are large in size, planning for future expansion is essential. So for that we are going for analysis. And third one, system being planned or to be optimal with respect to cost, then performance and operational efficiency. So whatever we are planning, if I want to install more power plants, okay, then I need to look after this optimal condition as well as with respect to the cost, performance and operational efficiency. And fourth one, for the maintenance of generation, transmission and distribution facility, we are going for this analysis. So these are the blocks we are having, that is planning, implementation of the plans, monitoring and comparing plans with results. Okay, so whatever you are planning, we are implementing, then we are monitoring whether it is correct or not. If there is any deviation in what we plan, then we need to take a corrective measures or corrective action, and again this cycle continues. Okay, so this is this block diagram explains about the planning and operational analysis of the power system. So what are all the steps? First, planning of a power system, implementation of the plans, monitoring system, compare plans with results. If no undesirable deviation occurs, then directly go to the planning of system. If undesirable deviation occurs, then take corrective action, then go to the planning of the system. Okay, so corrective action is necessary only if there is a deviation. Otherwise, we can directly go to the planning of the system, directly from monitoring.
So in this video we saw about the need for power system planning and operational studies. So in the next class we will be seeing about power scenario in India. What is the present situation and the past as well as future situation of electrical power generation, transmission as well as distribution. So thank you, Unnanda.